everyone and welcome to this video. Okay, let us continue our discussion. Last time in the last video we discussed about translation, like how we can move the graph up, down, left, right. Today we want to see about reflection, stretch and compression, like how when the graph will be reflected and how we can stretch or compress. Okay, let's see. We have a function f of x is equals to x square. Okay, what will happen if you change the input value? Okay, like let make it f of negative x. If you change the sign, what will happen to the output? Negative x square. You will again get x square. So if you do it through table, you see it will have no change in your graph. You have x, you have f of x. Change some values: 0, 1, 2, 3. What will be f of x? It will be 0, 1, 4 and 9, because based on our function this is x and this is f of x, which is x square. If you change the input of this function, if you change the input, it is x, 0, you change the sign, negative 1, negative 2, negative 3. So what will be f of x? It will make any difference? No. Why? Because the square will finish it. Because it's a square, so negative will have no impact. So we can say what? The graph of both is same. Either you draw on the right side or you draw on the left side, it's the same. You will get the same reflection. So when you want to flip it, it's the same. So when you will change the input value, like the sign of the input value is changed from positive to negative, it will have no impact on the graph. It will be same. The reflection will be same. Okay, you can say it like its own reflection. You've seen it here because you change the sign from x to minus x, like you change it to minus x, you see there's no change in the output, so the graph is the same. Yes, but look, if you change the output, like for example you have f of x is equals to x square, this is your function. Okay, if you make a table of it, what we will get? X, f of x. We have 0, 1, 2, 3. We'll get again 0, 1, 4, 9. This is x and this is f of x, which is x square. What we do? If you change the sign of the output, you make it negative f of x. It will be what? The output will be negative x square. Now what will happen in this case? We change the output. So you have x and we have here negative f of x. It will be 0, 1, 2, 3. It will be 0, negative 1, negative 4 and negative 9. So what happened here? You see the output changed. So if you want to see it on a graph, like what will happen here, let's copy this and use this as a reference. This is the graph for f of x. Like we have one graph. This is f of x is equals to x square. This is going up 1. Now this graph, that's negative f of x. What will happen to this? It will go downward. Same graph which is up will be only flipped across x-axis. Okay, so what we learned so far, if we summarize it, we can say that if you change the input of the graph, it is the same. There will be no change. Graph is the same. The flipped graph is the same. Yeah, however, if you change the output, if you have f of x is equals to x square and you change the output, okay, then it will be negative x square. Then what will happen? The graph will flip across x-axis. So these are the two things in the flipping part. Now let's talk about stretch and compression. like when the graph can stretch and when it can compress. Let's say we have f of x is equals to x square. F of x is equals to x square. Okay, if I quickly draw the table again, we have x, we have f of x, 0, 1, 2, 3, we have 0, 1, 4 and 9, because it is what? It is of x square. Now we do what? We change the input to a number. We say like f of, let's say, 1 over 2x. What will be the output impact? Output will be change also, 1 over 2x whole square, right? Because we change the input variable. Now what happens here? If you see, what I will do, I will take the same number input so that I can relate the values. Like now this is like a function, so it gives values on these domains. So 0 is 0, 1 is 1, 2 is 4, 3 is 9. I will use now this function, but I will use the same values to compare them, like what change it makes on 0, 1, 2 and 3. If you see, before you have multiplied with the number, now before it was 0 on 0, still it is 0 on 0, but now if you see 1, before on 1 it was 1, now it is what? 0.25. The value will be 0.25. Before it was 2, 4, now it is what? 2 over 2, 1, 1 square is 1, now the value is coming 1. On 3, before it was 9, now it is coming what? It will be 3 over 2, because the function is what? 1 over 2x whole square, right? So 3 over 2, it is what? 1.5 square is what? 2.25. So what is happening? Compare. If you see, before on 0, 0, here on 0 it is 0. Let us try to plot it. Sorry, let us try to see. This is the graph for f of x is equals to x square. Now what is happening here? Here is 0. This graph 0, it is still 0. Okay, we can say that on 0 it is still 0, but on 1, before it was 1, now it is what? It is 0.25. On 2, before it was 4, now it is what? It is 2.25 something here. So what you see, what you observe, if you see, the graph is opening what? It is opening, it is stretching. It will stretch. Same on here, this stretch. So what happened? We can say that because of this change, graph is what? Graph is doing stretching. How it is stretching? It stretch away from y-axis. It is stretching away from y, because see, we just added 1 over 2, multiplied it 1 over 2. Before it was near to the y-axis, now it is what? Now it is stretching away. How much is the stretch? Based on this value. So can we write it in journal? Can we write journal? We can say that if we have f of, let's say, 1 over bx is equals to 1 over b x square, using the parent function of f of x is equals to x square. If this b is included here and this value of b, absolute value of b, is greater than 1, then what will happen? The graph will stretch. How it will stretch? Away from y-axis. How it is possible? We just use an example here. We saw, see here, the graph stretched, and if the value is in between 0 to 1, it will happen, it will do opposite. It will go towards. You can check this case. Okay, this is the rule. Towards x, towards y-axis. Okay. Now one more thing. Now what if we change the output? Like this is like multiplying input with some number. Now what if you multiply the output with some number? Then what will happen? What will be the change? Let us do that change now. We have, for example, f of x is equals to x square. Okay, we times it with a number, let's say a into fx. What impact will be on the output? It will be a x square. Let's see what we get here. Through a table, to explain I will use a table. X, we have 0, 1, 2, 3. F of x will be what? 0, 1, 4, and here it should be 9. Let's say over a, let's take it as let's take 2. So it will be what? 2 into f of x, right? 0, if I input the same 0, it will be what? Now before it was 1, now it times it by 2, so it becomes what? 2, right? Before it is, this is the graph of x square, this is the graph of, sorry, the points of 2x square. So 2 4s are 8, right? It was 9, now it will become what? It will become 18, because 2 9s are 18, right? It is x square, 2 1 4 and 9. 2 times 1 is 2, 2 times 4 is 8, 2 times 9 is 18. Now if you use the same plot which we used before to understand it, if we try to do the plotting here, let's see if we can understand it. We are in 0 0. This is done, one of them is done. This is f of x is equals to x square. This graph is for x square. Now see what is happening here. Before, when x is 0, it is 0, it is 0 also. When it is 1, f of x is 1. But after multiplying it with a number, what happened? It became 2, like it gone here. Now it is 1, now we say it is here on 2. Before it was 2, it was 4. Like when x was 2, the y value was 4. Now what happened? When x is 2, y value is 8. It is someone here. If before the value of 3 was 9, like on 3, yes, 1 2 3, it was 9. Now on 3 the value is 18. So if you draw it, what you will see? You will see that it is going away from x-axis. Sorry, the graph is going away from x-axis. How I can say it is going away from x-axis? Because before, you see, when it was 0 it was 0, 1 it was 1. Now it is doing what? It is stretching away. How you can say that? You see here, let's take the value of 2 here. Let's take x2. Before it was 4, it was, let's say this is 4, so it was near to the x-axis. Now it is 8, means what? It is gone away from the x-axis. So we can say that it stretch away. It stretches away. You got the point? Like it is 1, it is 1. Now it is 1, it is 2. Why? Because we multiplied it, the output, with some number. Okay, let me summarize it. If I summarize it, it is something what we have done so far. According to the examples we have studied for reference, we can say that if the input value is changed, okay, it will have no impact on the graph. It is the graph reflection is the same. Okay, but if the sign of the output value is changed, okay, then what will happen? Graph will flip. Like if it is x square is opening upward, minus x square will open downward. Secondly, what we saw, how we can do the stretching and compression part. If you change the input with some number, the graph will stretch. When it will stretch? If the b value is greater than 1, absolute b value. Absolute value means even if it is negative, it will have no impact, it will still be positive. Okay, absolute value. And if the output value is changed, then what will happen? The graph will stretch away from the x-axis based on the value of a. Okay, now let's do some examples. Let's try to put these concepts on a question. We have g of x is equals to minus 4x square. We want to plot it. See, there is no h and k here, so there is no translation in the vertex, right? It is h value is 0, k value is also 0. So in the first video we discussed about moving the graph left, right, up, down. So there will be no movement in this graph, right? Because h is 0, k is 0. Now let's see how we can change this a value here. Eventually it is a na. So g of x is minus 4x square. You see here, if you compare it with the function, parent function, f of x is equals to x square, there is a negative involved. The output is changed. The output is now negative. So it means what? If f of x, we have the graph of f of x like this, right? We saw that if output changes here, if the output change to negative, the graph will flip down. So we know one thing is for sure, that our graph will open downwards. Why? Because there is a negative here. This negative, we change the output. Agree? Now moving forward, we have a negative 4. So output is timed by a number which is 4. So if you see this part which we learned here, we are multiplying the output with a number. So it means what? Based on this a, our graph will do what? It will stretch away from the x-axis because it is greater than 1. It is 4, so the graph will stretch away. How much it will stretch away? 4 units. Like 4 times it will stretch. You see in this example which we did here, in this part we discussed here, like it stretched 2 times. It stretched double. It was 4, it became 8. It was 9, it became double. So even if it go forward, it will be like double. The stretch, the graph is stretched, right? So what will be the output graph? We will get the graph like this. This will be the graph. If you see, this is the f of x is equals to x square, and what we did, we shifted it. How we can have, with transformation we did, we have the stretched and we have the reflection part. It's flipped because there was a negative sign involved. This graph is for this for this one. Now you see, before on 1 the value of the graph was 1. Now on 1 the value of graph is negative 4. Why? Because it's 4 units stretched away from x-axis. That we learned before, that if the output is changed, if multiplied with a number, what impact it will bring on the graph. Okay, let's see another question. Half x square. In this you see the input value is changed. The input of the graph is changed. Like the function is what? F of x is equals to x square. Here the input is changed. See what we learned in the input change. We saw that if the input is changed with some number, the graph will do what? It will stretch away from the y-axis based on that stretch. So let's see what the graph of this question will be. We have the graph. It will be like this. How I can do that? How I got this graph? This is what? This is x square, and this g is half x square, right? So we got this. This is the parent graph, right? Now we want to see how much stretch we have to do, because this is b, the denominator is b, it is 2, it is greater than 1, so the graph will shift. How much it will shift? 2 units. Like it will shift, shifting means like stretch away from the y-axis. It will stretch away from the y-axis, because when the input change, graph is stretched away from the y-axis. If the output is changed, graph is shifted from the x-axis. Now before on 0 is 0. Now you see the value of graph when it was 1, it was 1 here, but now it's stretched. How many units is stretched? 2 units is stretched. Now the graph will go beyond it. Now the value of 1 is, now you see the stretch. This is the stretch in the graph. I hope you understood it. Try to solve some examples for better clarification. Okay, this is the reference tables you can use to do the stretching and compressing part. Next time we will talk about how to plot a graph if it is not in the vertex form, but if it is in the standard form. Like this is the vertex form. So far we are talking about the vertex ax plus k, but what if the graph is in this form, the standard form, ax square plus bx plus c? How we can do plotting for this type of graph, we will see, the function, we will see it in the next video. Thank you so much guys. I hope you understood it. If you like it, please also subscribe it. Thank you.